All right, guys, we're on Unit 10, Day 5, and this is called the remainder theorem. And it says, how do you algebraically determine if a value is a root of a polynomial equation? And so we could, how do we determine if a root is? Well, I guess we could see it graphically if it's on the x-axis. Or we could go ahead and plug in root. Plug in the root or 0 number / value. And if the output equals 0, that means it lies on the x-axis and would be an x-intercept, thus being a 0 or a root. All right. Then it says in this little picture here to identify the roots. And so our roots look like it's x equals -2 and x equals +2. Okay? And then they want to know what are the factors. So the factor would be x plus 2 and x minus 2. And so those would be my factors. Okay. And so here we go. In number 1, it says given p of x equals x squared minus 8x plus 18, they want me to evaluate p of 2. So we're going to go ahead and do p of 2 equals, which means all the x's come out and 2's go in. So this would be 2 squared minus 8 times 2 plus 18. All right, and so this would equal 4 minus 16 plus 18. And that's going to give us 6. And so p of 2 equals 6. All right, which means the point 26 is on this graph. All right, so now they want to know, is 2 a root of that? Well, when we plug 2 in, we didn't get 0. And so we're going to say no, because p of 2 doesn't equal 0. Okay, remember, in order to be a root, you need to be an x-intercept, and all x-intercepts have a y-coordinate or an output of 0. Okay. In part C, they said, would the expression x minus 2 be a factor? Well, if x equals 2 is not a root, then x minus 2 can't be a factor. And so we're going to go ahead and say that x minus 2 would not be a factor because x equals 2 is not a root, because p of 2 doesn't equal 0. All right, so hopefully that makes sense. All right, part D, it says, would there be a remainder if, or when simplifying this? All right, if so, what would it be? Well, we know that this is not going to go in a whole number of times, okay, because it's not a factor. So therefore, there would be a remainder. And if you remember, when we plugged 2 in the part A, we got out a 6. So we don't have the 0.20 on our graph, but we do have the 0.26. And so, yes, there's going to be a remainder. And it would be 6. Okay, now in part E, they're going to ask me to verify using long division. So we're going to go ahead and take that x minus 2 and divide it into x squared minus 8x plus 18. Okay, so at the bottom, we should have a remainder. All right, so what we need up at the top is an x, so that x times x is x squared, and x times -2 is -2x. Put our minus sign, and remember we have to use it twice, each one for each set of terms. So x squared minus x squared cancel, and this is -8x minus a -2 which is really negative 8 plus 2, which is negative 6x. Bring down our plus 18. And now we're back at the top, and we're trying to figure out what we need, and that answer is going to be a negative 6, so that the negative 6 times the x is the negative 6x. Negative 6 times negative 2 is plus 12. Put up our minus sign and go ahead and subtract. And we have negative 6x minus negative 6x, and so that's negative 6x plus 6x, which cancel, which is what we wanted to happen. And then we have 18 minus the 12, which is 6. There's nothing left to bring down, and there it is. We just verify that that's the remainder. So we have quotient remainder form, which that's my quotient, plus my remainder, which is 6, over my divisor of x minus 2. All right, but right there, we verified it. Okay, all right. In number 2, it's asking us if p of x equals 3x squared plus 7x minus 20, is x plus factor of p of x? So we could do this 2 ways. We could do long division, or we can now use what we call a remainder theorem. This is the long way, and this is the shortcut. All right, so we'll take the long way first, so you'll appreciate the shortcut when we do it. So if I go ahead and long divide x plus 4 into a polynomial, oops. Okay. If it goes in, there won't be a remainder, which means it's a factor. Okay. So up at the top, I'll need a 3x, so that 3x times x is 3x squared. 3x times 4 is 12x. I'm going to go ahead and subtract them. 3x squared minus 3x squared cancels. 7x minus 12x is a negative 5x. Bring down our minus 20. And x, we're going to need a negative 5 at the top. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20. And we end up with negative 5x minus negative 5x is really negative 5x plus 5x, which cancel. And then we have negative 20 minus a negative 20, which is negative 20 plus 20. And so we get 0. And there's nothing to bring down. And therefore, because this is a 0, this is a factor. And so now we can say x plus 4 is a factor because the remainder is 0. Okay. So now we could have also divided it to see if it was a factor. That would actually been a third way we could have done it. All right. But now we'll take the shortcut and we'll do the remainder theorem. Okay. If you want to know x plus 4 is a factor, that would be a solution of x equals negative 4. And if x equals negative 4, we can take out all the x's and plug in negative 4. And we're going to go ahead and see what this gives us. We could literally just type it right into our calculator exactly the way we wrote it. So type in 3 parenthesis negative 4, close it, square it. Those parentheses are super necessary. Plus 7 times negative 4 in parentheses, and then minus 20. And when we hit enter, our calculator tells us 0. And so we can go ahead and now say that since p of negative 4 equals 0, negative 4 is a 0, and x plus 4 is a root. Or I should say factor. Doesn't matter. The question said factor. That's why I switched it. Okay. And that one's finished. So you can see either way we'll answer the question, right? But if they ask us to use the remainder theorem, we have to do it this way. Okay. If they don't give us an option, we could do long division. Okay. Like we did on the first side. Or to be honest with you, you could also factor the trinomial to see if you can come up with the factors, and then you can answer the question if x plus 4 was one of them. All right, guys, I'll see you on the back side of notes.